Hello guys, and welcome to the part 2 of our procedural microchip tutorial. In this part we will be modeling the pin of the microchip. It's a little bit longer than I originally expected. I thought that in 10 minutes we will be done, and now it's again a 20-minute video. I was almost at the finish, and then I applied a reflective material to the pin, and bam, there appeared bad normals on it. Well, what to do now with it? I found a solution, but I decided not to show you just the correct method how to make the pin, but also the method that led to the problem with the normals. Because I think it's equal as important to know what to do as to know what to avoid to save yourself a huge amount of time. Well, let me just show you. Procedural microchip tutorial part 2, modeling the pin. Let's get started. I will start the pin with an arc, not the arc of truth, but a curve arc. So let's add here a arc node. Plug the curve into a viewer so we can see what we are doing. Now the resolution here will be 12 points, radius will be 0.25 millimeters, and the sweep angle will be 90 degrees. Okay, let's zoom in. And I will want to rotate it on the x-axis and then also translate it on the z-axis downwards. So let's add here a transform geometry node, draw out from the translation a combine xyz vector, and for the rotation I will rotate it with 90 degrees, and for the translation on the z-axis I will translate it with the radius actually. So let's draw out a value of 0.0025. Multiply this value by -1 to move it on the negative direction of z-axis. Okay, this point has to be on the origin. Now, to solidify the geometry, we will use a curve to mesh node with a quadrilateral profile. So let's add a quadrilateral plugged into the profile curve. The width of it will be 1 millimeter and the height of it will be 0.15 millimeters. Now we have the basis of our pin. Okay, let's also enable the fill caps. When you look at the list of the faces, the caps here are shaded flat. So those are the indices that we will need to extrude. Let's add here a extrude mesh node. And the selection I told was 44 and 45. So let's add here a compare node. I will need the equal mode here with a, so I will be comparing an index to a integer number 44 and 45. Let's start with this extrusion. Let's move it a little bit out to the side. The scale will be 1 millimeter, so 0.001. No, that's too much zeros, like that. And you can see that the extrusion is following the normal of the face. So to fix that, let's add here a scale elements node, plug it in front of the extrude mesh, and use a single axis mode. Now that hit our comparison, and the axis will stay on X and just zero out the scale, and also not completely, but just the selection. That zero out the scale on the z-axis, so on the x-axis, and extruded it straight there on the x. Now let's extrude again actually. So duplicate the extrusion node, duplicate also the setup for the for determining the selection. Let's plug it here. The index this time will be 44. So the other sharp face and the scale or the offset scale will be 1.25 millimeters here. So it's going downwards. Now you can see there's already some shading issues. So let's try to add here a set shade smooth node and plug it here. And it's not working correctly. When you set shade smooth, it should be shaded smooth completely, including the straight parts. There is a problem when you extrude the caps of the curve to mesh profile, and we will have to fix that. Let's actually also apply here a material. So let's add here a set material node. After the shade smooth, let's select the default material that we have in the scene, and let's turn up the metallic value all the way to 1 and decrease the roughness to something like 0.15. Let's select the object, hit F to frame it into the view, and also let's return actually to the geometry nodes because the viewer node is not active in the shading tab. So let's separate the connection from our capsule and actually plug the pin to the group output. Now we can get rid of the viewer. For the moment, we will need it a little bit later. Okay, let's go to the shading tab and take a look at the pin, and we have to again fix the clipping issue with the camera. So let's just decrease the clipping start to a small value. Actually, I will use even 0.1 millimeter. Yeah, you can see the normals definitely not are okay. What I did when I first tried this thing for the tutorial was in the shading I enabled harden normals. There appears a warning message, enable auto smooth in object data. So let's go there, go to the normals and enable auto smooth. This fixes it, but only in part. The top part still stays with the ugly seam. So we will have to use a workaround. Back in the Geometry Nodes tab, let's actually duplicate the entire geometry or the setup that we made, and add here a transform geometry node. Now let's plug the original one here and add here also a join geometry node. Let's plug the output of the join geometry into the group output, and now we will just join the transform geometry, and I will translate it on the y-axis with 2 millimeters because I will want to compare the result of the workaround with the original result. So let's move it a little bit downwards and also move the scales and extrusions to the side because we will need a bit of a space here. Okay, so what I will want to do is actually disable the caps, or disable the fill caps, and instead of it I will select the edges around the caps and make a polygon out of it. Also, let's actually disable the bevel modifier so it doesn't bother us. And let's add here a separate geometry node. We will separate the edges. We just need to select them. Well, I made the experimentation for you, and what we need to do for these edges is to select everything that is larger than index 88. So let's add here a compare node, and we will be comparing anything that is greater, or any index that is greater than 88 will get selected, and actually we can see anything because I need a viewer node here. Okay, so you see this is the first polygon that we need to make. Unfortunately, Geometry Nodes doesn't have any means of creating a polygon from edges, so we will have to be creative and use a convex hull. This creates an object around the area, but unfortunately it's an object, and in this case we have two faces. We have front and rear face, so we will have to delete it. Now let's add a delete geometry node. Enter face here, and obviously we will want to select which face we want to delete. So let's add here again a comparison. This time it will be the equal mode. Again, use a index attribute, and now we will have to choose from 0 or 1. Which one needs to be deleted, that we will determine later. Now Since we will use the same setup also for the bottom polygon, what we can do is make a group from this. So let's select these nodes, right click it and click make group, or the shortcut for it is Ctrl G. It will automatically plug in the inputs that we had as a group input. And we need one more, which is the ID of the face that we need to delete. So let's plug it in into the group input, unhide the side panel. Let's go to the group and let's name it index to delete. Okay, go one step up, and all the nodes got pretty nicely grouped into this single node. Now we will reuse that for the bottom face or bottom polygon. So let's replug the selection here, or the selection setup. Plug it actually into the viewer. The problem here comes, okay, we don't have a geometry plugged in. So we have the same selection, and the problem is here that the bottom face is somewhere in the middle of the indexes. It starts actually at index 44, and we have to limit it from the top. So what we will do is duplicate the comparison node, set it to less than or equal, and actually make a setup for it, so we don't have to set both of these values. I will add here a integer node with the index of 44 and add a value of 3 and not 33, just 3. And the result will be plugged into the B socket. Now to combine them, we will use a Boolean math with a logical AND. So both of these conditions have to be true at one time in order for the result to be true. And now with this we have a bottom face. There is actually a mathematical dependency between the resolution and the starting and end points, or end numbers of the IDs of the edges. I will talk about it at the end of the video, so make sure to stay until the end. Okay, what we can do now is to join the faces that we just made with the original curve to mesh. So let's add here a join geometry node and just simply plug in all the geometry into the join geometry, and instead of the curve to mesh, we have here this. Now, well, let's add here a, oh, I didn't want to reset that. Let's add here a set shade smooth node to see how our shading is going. Well, not really well. First of all, we need to actually merge the vertices of the polygons and the lofted mesh. So let's add here a merge by distance node. The distance, we have to keep it quite small because the scale of our scene is very small. We are working on millimeter scale. Okay, the top face, we chose a correct index. We will notice it by the shading of it, because if you choose a wrong index of the face, you will see that the shading is flat here. So let's return to 0, and the bottom face is obviously wrong, so we have to change the deleted index to 1, and now the shading is working, I think, pretty well. So let's get rid of the viewer node and actually plug the geometry into the scales and the extrusions. Well, obviously the indexes have changed now, so we have to fix that. The first index is 0, actually. That is simple. And you can now already see with the bevel modifier disabled that the shading is becoming correct. The last index for the face to extrude is 45. It's actually the index of this edge plus 1. So you can see that's so much better. And also when we enable the the bevel modifier, disable the harden normals, and go to the shading tab, you can see now that the shading is so much better than at the original one. So back to the geometry nodes laid out, and let's actually finish the pin. Now we can get rid of the original pin setup and work only on the new one. What we will do is extrude this part a little bit further and taper it. So let's move these nodes aside. Copy the extrusion. Now plug in again the selection. The idea of that will remain the same for the rest of the extrusions and scales, so we can always reuse it. Or you can actually use the top socket from the extrude mesh. It's actually the same selection, so you can either use that one or the previous selection setup. I will stay with this. The scale for that will be 0.3 millimeters. Now let's duplicate the scale elements node, plug it here again, reconnect the selection. Now single axis mode remains, just change the axis to Y. And the scale not to 0, but to 0.45. Okay, now we can continue with extrusions. So duplicate the extrude mesh, reconnect the selection. This time we will extrude it with 2.5 millimeters, actually 0.0025. And the pin is coming along nicely. So again, let's duplicate the extrusion. This time it will be a final one. The selection again. The height of it will be 0.4 millimeters this time. And again, let's copy the scale elements node, plug it here, reconnect the selection or reuse the selection. And the scale this time will be 0.35. So we have this shard part of the pin. So this is the pin this is the finished model of the pin. Let's enable back the hardened normals, and we have a nice model of that. Well, I told you that I will tell you about the mathematical way to determine the indices. Well, I experimented with it all depends actually on the resolution of the initial arc that you make, because when you decrease it, for example, to 8, we will get all screwed up. So now we're back with the resolution 12. Let's actually input it as an variable, or as a value, as an integer value, and we will depend on that. I don't know if you noticed it, but actually this number is half of the top selection for the faces, and the index of the face that we are extruding is this value plus 1, and it actually works for all the resolutions from 4 to 36. What I tried. And the formula to calculate it is actually to multiply the resolution by 4. So let's add here a multiply node. The value will be 4. Then to subtract from 4 from this value, 4 from this value. That will give us 4 by 12 is 48, minus 4 is 44. So we can replug actually this this integer to this socket actually, and we have to change the mode to subtract. Okay, so now what we can do is duplicate the add node and change the value to 1, and just connect this value and replug and replace the constant with this calculated value, and everything stays in place for the moment. This one is double of this, so actually I will put it like that. We can multiply this result by 2, and again connect it to the B socket, and yet everything stays in place. So let's try some other values like 4, 8. Also, you can notice that the lower the number of the resolution, the bigger the angle. So you can also also adjust it to your liking. Well, let's try a higher resolution, 24, and we are all messed up. Actually, not really. What we have to do is just flip the faces that we are deleting. So let's flip that to 1 and this one to 0. This happens sometimes also when you change the radius of the arc. So let's change it to 1 millimeter. And actually here it stays the same, but if we go to lower value like 12, we have to adjust the deleted faces again. So, but it works. It's definitely a working solution. So let's keep it at 12 the resolution and the radius at 0.25 millimeters. And now really the pin is finished. Let's take also a look at the shading tab, and everything seems nice. Now again, back to the geometry nodes tab. I think I will organize it a little bit. Okay, so the final arrangement looks something like this. Now let's just select everything except for the group output, and like last time in the node wrangler, let's click frame selected, and then in the node label this as a pin. And with the pin finished, that's where we will wrap it for today. In the next part, we will take a look at the distribution of the pins along the side of the capsule and also assign materials to both the pin and the capsule. So make sure to hit that subscribe button to get notified when the next part comes online. Thank you for watching and see you at the next part of the tutorial.